Hello and welcome back to KINE 404, an introduction to epidemiology. My name is Richard Armenta, and in this video we're going to talk about incidence rates and how to calculate an incidence rate. So before we get started, let's first remind ourselves what incidence is. So incidence describes the rate of development of a disease in a population over a certain period of time. And incidence can either be a rate, which is what we're going to calculate in this video, or it can be a proportion, which was our cumulative incidence that we calculated in a previous video. Our incidence calculation contains three elements: the number of new cases, the population at risk, which we've described previously, and time, or the period during which the cases are occurring. An incidence rate, as opposed to cumulative incidence, describes disease occurrence as it is related to the amount of time that each person is observed in our population. So this is an important distinguisher between incidence rate and cumulative incidence because it actually takes into account the amount of person time, which is the new concept that we're going to talk about in this video, or the amount of time that each person is observed as being at risk for the particular disease that we're interested in studying. This is an important calculation because incidence rates can take into account the fact that most of our populations are open or dynamic populations, where they're fluid and people are constantly moving in and out of the population. And this is particularly true when we're conducting research studies, where if we're following up people for 1, 2, 3, 5, 10, 20 years, where we're trying to examine who develops disease over a period of time, inevitably some people who we start following aren't going to be able to finish the entirety of the study. But with incidence rate, we can use the data that they contribute to get a better picture or a more accurate picture of what the rate of new disease occurrence looks like in our population or in our particular study. So incidence rate is the number of new cases or incidents of disease per unit time, which is what makes it a rate. And the denominator in this calculation is a combination of the number of people and the amount of time that they are followed, which is what this new concept person time is that we'll talk about. So our formula for incidence rate is similar to that for cumulative incidence, with one major difference being that our incidence rate is equal to the number of new cases during the time period, which is the same as we have for our cumulative incidence. And we also have to make sure that if somebody's included in that numerator, that they also have to be in the denominator for that time period that we're doing our calculation. But what you'll notice is much different for our incidence rate calculation is our denominator. And now, instead of being the total population at risk at the start of the time period, it is what we call person time at risk during the observation period. And we'll talk about person time rate in just a second. The time period must be specified still for our incidence rate calculation, and in order to be able to determine the number of new cases of disease, we have to have ongoing observation or testing, meaning that we have to be able to know when people are actually developing the disease that we're interested in. And the same thing as for our cumulative incidence calculation, we still have this multiplier that we're going to use to help us interpret our calculation, and we'll go through an example of using that multiplier today as well. So this new concept that we're talking about in our incidence rate calculation is called person time, or it might be more intuitive to call it person years or person months or days of observation, because essentially person time is an estimate of the actual time at risk in either years, months, or days that all participants in our population or in our study are contributing to being at risk of disease that we're interested in studying. In most studies, people are followed up for different lengths of time, and people will get the health outcome at a different time during the follow-up. So if you remember from one of the limitations from cumulative incidence, it was the fact that if we were following people for 5 years to see who developed some cancer, in that cumulative incidence calculation, a person who developed cancer after 2 months of follow-up would be treated the same as a person who developed cancer after 2 years or 3 years of follow-up. But they're actually not at risk for the disease for the same amount of time, because somebody who was diagnosed with the cancer that we were interested in, who got it after 2 months of being in the study, they really were only at risk for that disease for 2 months, and then they developed the cancer. Whereas somebody who didn't get the cancer till 2 or 3 years into the study is actually at risk for 2 years or 3 years, depending on when they got it. And so that amount of time is much different. And that can actually be taken into account when we're calculating our incidence rate, whereas for our cumulative incidence, we're just looking at who's starting out as at risk and treating everybody as having the same amount of risk throughout the entirety of the study period. So to illustrate a simple example of what person time is, say we have an example of wanting to determine 100 person years. So what is 100 person years equal to? 100 person years could mean that we followed 100 persons for 1 year. So what that means is we have 100 people in our population or in our study. We follow them each for 1 year, and that equals 100 person years of risk. We could also, to get 100 person years of follow-up time, follow 50 people for 2 years, because each of those 50 people would contribute 2 years of risk, and that would also equal 100 person years. So as you can see, as I'm doing these calculations, we can come up with the same amount of person years with different population sizes by following them for different lengths of time. So we could also follow one person for 100 years and come up with 100 person years of time, or we can follow 200 people for 6 months, where each of those people only contribute half a year. So 200 times 0.5 equals 100 person years, which I'll abbreviate occasionally as PY as well. The other thing that you could also do is you could follow people for different amounts of time. So we could follow, say, 50 people for a year, and then we could follow 50 people for half a year, and we could follow another 50 people for 2 years, and then we can average out the amount of time that all of those people were followed, and we can come up with the amount of person time in total from all of those. So to better illustrate this concept and to illustrate calculating our incidence rate, let's go through an example. So let's look at this scenario here where the problem is going to ask us, what is the incidence rate of disease per 1,000 person years? And we're going to calculate it from October 1st, 2004 until September 30th, 2005. And so let me first orient you to the figure that you're seeing, and you're going to see figures similar to this throughout the semester and on your exams and homework, so make sure you're comfortable going through these types of examples. So this figure represents 10 new cases of illness in a population of 40 persons. So what that's telling us is we have a sample size, N equals 40, and in this figure, we have N equals 10. So then that also means that we have 30 people who are not represented in the figure that you're being shown here, but we're going to assume that all healthy individuals, so those 30 people not in the figure, are at risk of getting the illness, and that'll come up again in just a moment. Each horizontal line represents one person. So we have 10 people in this figure as you go down here. And the down arrow, and we're going to look here at this legend, indicates the date of onset of illness. So if there's a down arrow, that means somebody got sick. The solid line, the solid red line across the figure, represents the duration of the illness. So essentially somebody was sick during that time period that the line is red. And the up arrow indicates the date of recovery. So that means that somebody recovered from the disease after they were sick. And the cross indicates a date of death. So that means if somebody has a cross, that they died on that date. Each box represents 1 month of time. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 months between October 1st, 2004 and September 30th, 2005. We also have 1 month on either side of that year that we're doing our calculation for to help us illustrate this concept. An arrow or cross on the line indicates that that event happened on the last day of the previous month. So given all this information, what is the incidence rate of disease per 1,000 person years? So to determine this, we first need to write out what our incidence rate formula is. Incidence rate is equal to the number of new cases during that observation period over person time at risk for the disease times our multiplier, and in this case our multiplier is 1,000, and it asks us per 1,000 person years here. So now we have two pieces of our formula that we need to figure out: our number of new cases, which we're going to get from the figure, and our total number of person time, which we're going to get from the information provided in the scenario description and from our figure. So the first thing that you'll want to notice is that you have 30 healthy people who are not represented in this figure. They're still part of your population, and we're assuming that they're all at risk for the disease. So that means that these 30 people that we wrote out over here, they're each going to contribute 1 year of duration of risk for the disease. So those 30 people in total are going to contribute 30 person years of risk for the disease. So now we figured it out for everybody who's healthy, who doesn't get the disease during this 1 year time period. Now we have to figure it out for these 10 people who are represented in this figure. How much person time are they contributing to risk for the disease? So in order to do that calculation, we have to add up the number of months that each person that's represented in this figure is at risk for the disease. So I'm going to write out months here up at the top, and then what we're going to do is go person by person, and we're going to calculate the number of person months that each of these people is at risk for the disease. So let's start out with person 1. Person 1 starts out sick, and then they're sick for the entire duration of the 1 year before they pass away from the disease. So because they're sick for that entire time period, they actually contribute 0 months of person time at risk for this disease, because they're not at risk during any of that time, and they're sick at the beginning of the time. Person 2 starts out sick, they're sick for 3 months, and then they pass away. So all of this time after is not counted because they've passed away and they're not at risk for the disease anymore. So that means that they contribute 0 months of time at risk for that disease. Person 3 starts out healthy. They contribute 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then they get sick. They're sick for the rest of the time past September 30th before they pass away, but they've contributed 9 months of person time at risk for that disease. If we go to person number 4, they start out healthy, they contribute 1 month, they get sick, and then they're sick for 5 months, and then they pass away. So none of the rest of this time counts towards their risk because they're not at risk if they're no longer alive. So person 4 contributes 1 month of time at risk. So we're going to keep going through all the rest. So person 5 contributes 1, 2, they get sick, they're sick for 9 months, and then here at the end, once they get better, they're at risk for that disease again because this disease can reoccur. So that means they contribute 3 months. Person 6 contributes 1 month here, they get sick, they're sick for 9 months, and they contribute 2 more months when they recover because they're sick again, they can get sick again. And one thing to note is that that's not always the case, that for many diseases, once a person gets sick with it, especially for many infectious diseases, that once you get sick, you develop immunity and you're no longer at risk again. But for this particular scenario, we're going to assume that people are at risk for this disease again, because we haven't actually indicated what the disease is. For person number 7, they start out sick, they're sick for 3 months, and then they pass away. So that means they contribute 0 months of risk. Person 8 also starts out sick, and they're sick for the duration, so they contribute 0 months of risk. Person 9 starts out healthy, they contribute 1 month, they're sick for 9 months, and then they pass away, so they only contribute 1 month. And then person number 10 starts out healthy, they contribute 4 months of risk, they get sick for 3 months, and then they pass away, so none of the rest of this time counts, so then they contribute 4 months total. So if we add all of those up, 9 plus 1 plus 3 plus 3 plus 1 plus 4, that equals 21 person months. So now, the problem asks us to calculate the incidence rate per 1,000 person years. So that means that first, in order to calculate our rate for person years, we have to divide that person months to come up with number of person years. So to come up with the number of person years from that 21 person months, we divide 21 divided by 12 because there are 12 months in a year. So if we do 21 and we divide that by 12, we're going to come up with 1.75. And that's 1.75 person years contributed by the 10 people who are represented in this figure. So now we have 1.75 person years in total contributed by the 10 people in the figure. We need to add that to the 30 person years who were contributed by the healthy people who are not represented in the figure. So I'm going to put that over here. And that gives us in total 31.75 person years. So now that number, I'm going to switch to a new color, becomes our denominator for our incidence rate calculation. I'm going to shorthand denote incidence rate as IR. So now our numerator we still have to figure out, that's the number of new cases, but our denominator we just calculated as 31.75 person years, and we know our multiplier as 1,000. So now we need to figure out the number of new cases. So if we look at this figure, we need to count up the number of new cases that occurred from October 1st, 2004 until September 30th, 2005. So if we go through, person 1 didn't get sick during that time period, person 2 didn't, person 3 did, so we're going to circle that, person 4 did, person 5 did, person 6 did, person 9 did, and person 10. They all got sick. So if we count those up, there's 1, 2, 3, 4, 5, 6 new cases of disease during that 1 year time period. So now we just do the math and we do 6 divided by 31.75, and that equals 0.18896. And I'd recommend that you carry these out to several decimal places, and then we're going to multiply that number by 1,000, and that's going to give us 188.98. So that's per 1,000. So that is now our incidence rate for this particular population, and we would expect that there would be 188.98 new cases of disease during this time period for every 1,000 people or person years of time follow-up in our population. So this now gives us the number of new cases that we would expect to see depending on the amount of time that we follow up our population and the number of people in our population, and that's indicated by that number of person years. So I'm going to write person years here. And so our incidence rate is the number of new cases per unit time. So essentially, how many people do we have that we're following up during this time period? And that person time reflects the number of people and the amount of time they contribute to risk. The incidence rate is a more accurate estimate of the rate at which a disease occurs and a measure of risk of disease. And if we compare this to prevalence, which is a measure of burden of disease, the incidence is risk of development of new disease in our population. So the higher the incidence rate, the higher number of new cases we'd expect to see over a period of time, whereas the lower we'd expect to see a lower number of cases over a period of time. This incidence rate is a much more accurate way of calculating incidence than our cumulative incidence, especially when we have a dynamic or a fluid population where people are constantly moving in and out of it. But the cumulative incidence is still useful for overall understanding of the rate of disease. It just may not be as accurate as our incidence rate. If you have any additional questions about these calculations, please make sure you follow up and use some of the additional resources provided on Cougar courses. Thank you.